Okay, so here I have a unit circle. I have my center at the point 0, 0, the origin. I have a radius 1 for this circle, and I have a point P on the circumference of a circle, which is rotating around at angle alpha. So this is allowed to rotate anyway this way in the positive direction. So this would be it rotates 90, it rotates 180, and we can keep it going until it rotates all the way around 360. I can also go the other way. So I can start point P rotating this way. If point P reaches this would be minus 90 degrees, and we could carry on going, minus 180, and so on. So you have a point P, it rotates at angle alpha, and it goes either in the positive or negative direction. Okay, the first question is this. Draw diagrams to show the following angles. Mark in the acute angle that OP makes with the x-axis. Okay, so let's firstly draw this one. So I have my starting angle. I'm measuring from this point, and I'm going in the negative direction this way. So I will swing past 90 degrees, but I won't quite make it to minus 180 degrees. So I'm going to be somewhere here in this quadrant. Now, if I know this whole journey here is 120 degrees, I know that the full semicircle adds up to 180 degrees. So this little acute angle is going to be 60 degrees. Okay, let's look at this next circle. This one's being measured in the positive direction, so we're going this way. I'm going to get past 90, and I'm going to keep going, but I'm not going to make it to 180. So I'm here in this second quadrant. We've got quadrant 1, 2, 3, and 4. I'm in this second quadrant. Now, if I know if this journey is 100 degrees, and I know the full journey round is 180 degrees, I can see that this little acute angle is going to be 80 degrees here. Okay, third and final unit circle. So I'm measuring in the positive direction again. This time I'm going to make it all the way past 90, all the way past 180, and I'm going to carry on going for this full journey of 200 degrees. Now, thinking about this acute angle that I'm making with the x-axis, if this journey here, if this first semicircle was 180 degrees, and this full orange journey was 200 degrees, that leaves me displaced 20 degrees after that 180 degree line. Yeah, so that's where I am. Okay, let's have a look at this. Now, we use trigonometric functions to find the coordinates of this point P. So if I put in the angle alpha into sine alpha, it will return for me this y coordinate of point P. So it will tell me the y coordinate, or you could think about it as the y displacement here. If I put the angle alpha into the trigonometric function cosine alpha, what it's telling me is this x coordinate of point P, or you could think about it as telling you this x displacement. Just from the definition, we can actually calculate some of these trigonometric functions given certain arguments without actually having to resort to our calculator. So let's have a look at this. If I have sine minus 90, that means I am here. Okay, so I've gone minus 90 degrees, or I could do that as a little square there. And we can work out what this is. So I know this is my origin, 0, 0. Okay, I know this has radius 1. So let's think about what coordinates point P has on the circumference of the circle. Well, it's going to have coordinate 0, minus 1. It's 1 down from 0, 0. So I know sine tells me that y coordinate of P, which is here, minus 1. So I can say sine minus 90 equals minus 1. Okay, let's look at this. Sine 450. We are going to rewrite that. We know that the unit circle is periodic, so every 360 degrees it just flips again. So I can actually take 360 degrees away from that 450 and just say that that is sine 90. So let's have a think about what sine is going to be at 90. So here is 90 degrees. We've gone in the positive direction. Let's remember that this is 0, 0. This is, so this would be my coordinate of point P. So P here will have x is 0, y is 1. Sine gives me my y coordinate of P. So here, when sine is 90 degrees, that will be 1. So sine of 450 equals sine 90 equals 1. Okay, and finally cosine 270 degrees. So here is my unit circle, here's the origin. I'm measuring all the way around this way, and I am directly below once again. So notice 270 is in the same position as minus 90. Now, cosine gives us the x coordinate of P, so the x coordinate of P. So let's see if we can work that out. So I'm here at 0, 0. So my coordinates of P are going to be x is 0, y is minus 1. So the x-coordinate, when we have this angle of 270 degrees, is going to be 0. So I can say cosine 270 equals 0. Okay, let's move on. Okay, now we've seen that sine, cosine, and tangent can take different signs. They can be positive or they can be negative, as we've witnessed, or they can be 0. There's a really helpful little diagram that we can use, which basically will give us the sign, as in if it's positive or negative, of our trigonometric functions for each one of the quadrants. So in quadrant 1 here, all of them are positive, so sine, cosine, and tangent will all be positive. Here, only sine is positive, cosine and tangent are negative. Okay, if we keep working our way around, so sine is positive in this third quadrant, sine and cosine are negative, and finally in this last quadrant, we'll go with a nice yellow again, sine and tangent are negative, cosine is positive. So if we're in this fourth quadrant, so I've got quadrant 1, quadrant 2, quadrant 3, quadrant 4, let's look at what this question is saying. It is saying an angle is in the fourth quadrant. Decide the sign of each expression. Well, all we have to do really is read that cast diagram. So decide the sign of each expression. Well, I know sine is going to be less than or equal to 0. This one's going to be negative here. Cosine is going to be positive, so that's going to be greater than or equal to 0. And I know tangent is also going to be negative, less than or equal to 0. Okay, last but not least, express the following in terms of trigonometric ratios and acute angles. Sine 330 degrees, we have cosine of minus 240, and we have tangent of 495. Now there's two ways of doing this. We can either just draw the unit circle and kind of eyeball it, which is my preferred method, or we can use all of these lovely identities on the left. So firstly, let's do the old draw our unit circle and have a little think, which is my preferred method. So sine 330 degrees, we are going to be in that fourth quadrant. So we've gone past 90, past 180, past 270, we are right here. So this angle here is going to be that 330 degrees. Now we know then that this acute angle here is going to be 40 degrees. 40 degrees to get us to, oh hang on, excuse me, sorry, this is going to be 30 degrees to take us to 360 degrees. Now, if I was to draw another unit circle, and I had my point P displaced with an angle of 30 degrees. These two coordinates, this y coordinate in this top circle and this y coordinate in this bottom circle, will have the same magnitude. The only difference is the circle in the top, my point is displaced above the axis, so this will be positive, whereas this coordinate here will be negative, of course. So what I could say is I could say that sine 330 equals minus 1 multiplies sine 30. Okay, so just by eyeballing it, I can do that. I can also rewrite this using some of these identities. So what I can say is, I can say this. I can say that I'm going to rewrite sine 330. So sine 330, I'm going to rewrite that as sine 360 minus 30. Okay, so notice these are the same, nothing's changed. Sine 330 is the same as sine 360 minus 30. Now, if I apply this identity here, I can say that this equals minus sine, what's in my theta position here? My theta position is this 30, so I can say minus sine 30. So I get the same answer using that identity. Okay, so let's look at this next one. Cosine minus 240 degrees. Okay, so we're going to start by doing I like to call the eyeball and figure it out method. So we're going to be coming anti-clockwise this way. We're going to go past 90. We're going to go past negative 180. And we're going to be here somewhere at negative 240. So what is this acute angle going to be? This is going to be... 60 degrees, because we've got 240 minus 60. Now, this will have the same magnitude. So cosine of minus 240 degrees, we're looking at this x-coordinate. This x-coordinate here will have the same magnitude as this x-coordinate here, px, at this 60 degrees on the other side. The only difference is they're going to have different signs. So what I can say is cosine minus 240 is going to be the same magnitude as cosine 60, but it's got an opposite sign, whereas the one on the top is going to the left of 0, 0, so it's a positive number. On the bottom, I'm going to the right of 0, 0, so I've got a negative. So I can rewrite this as cosine minus cosine 60. Okay, so we can also rewrite this using these identities. So the first thing I can say is I can use the fact that cosine is periodic. So what I can say is cosine minus 240, it's exactly the same after I do a complete loop, a complete circle. So that's going to be cosine minus 240 plus 360. So cosine minus 240 is the same as cosine 120. Cool. So now I'm nicely sort of below 180 degrees. I can rewrite cosine using this second identity right here. So what I'm going to say is I'm going to rewrite my cosine as, instead of cosine 120, I'm going to call this cosine 180 minus 60. So notice that. So what's in my theta position? It is this 60 degrees. So I can say this equals minus cosine 60. Okay, nice. Tangent, let's do this last one. Let's just look at the identities for this. So tangent 495. So we're going to start off by saying tangent is periodic. So you can also do plus or minus here. So what I'm going to do is I'm just going to take away 360 degrees. So I'm going to say this is tan 495 minus 360, 495 minus 360, which is tan 135. Okay, now I can rewrite this using this second identity down here. Bosh, there we go. So what I'm going to say is, instead of tan 135, I'm going to rewrite this as tan 180 minus, 180 minus what gets me to 135? I think it's 45, okay? And now from the identity, 45 is in that theta position, so I can say that equals minus tan 45. And I've expressed them all as acute angles. Cool.